Good morning all. Today we will be starting with recursion. Fine. And in today's class, basically the flow would be somewhat different. Fine. Because I can, explain recursion to you all. Just give you, just take some like 15 or to 20 minutes, explain recursion and just do problems, right? But that won't help you. Fine. I will try to explain the approach, try to explain how you can observe any kind of recursion, and first of all, why we need recursion, right? So the flow of this class would be like why recursion first, fine, then observation, then we will discuss four methods for recursion. Basically, I mean there are four methods, but in this class we will do only two methods, fine, and then we will take problems for those methods, for those ways basically, fine. So this will be the flow of the class, and if there are some good questions also, uh, we will be like, if there are some good questions which are left, I will be making separate video for them in this week only, and you guys can watch that, fine. But if you understand how, if you just understand how to basically use this, you will be able to solve everything, right? So I think, yeah, no one is waiting right now. Okay. So yeah, so just focus on like what I will be teaching right now, fine, because this is actually really important question, a really important concept. And without recursion, if you're thinking to crack interview, then you can't, right? Because what basically this helps in optimizing our problem only, right? So recursion is really important. We will be discussing how. So like in our previous class also, you guys might have done recursion in Fibonacci series, right? Right, yeah, like Fibonacci series. We used to basically, what is recursion? Function calling inside a function, right? So we used to basically have some input, and then we used to check. We used to be like n minus one plus f minus two, n minus two, right? Uh, n only, not n. Yeah. So basically, we used to call the functions. We used to basically call the functions inside and right, and we used to in a way uh, decrease the input size, right? Decrease the input size. This can be any function. I've just written any function. So like basically, what I'm trying to say is that, just hold on, it's a little bit lagging. Yeah. In recursion, basically what we do is that we input is made smaller in a way, right? Input is made smaller in a way, but why is that happening? Like even in other courses or any other video you see in YouTube, you will see that people will just say that you need to the input in recursion, the input is made smaller so that the source space is smaller, sorry, the considering space is smaller, and we get the output very fast, right? But no one has like explained really well. I mean, there might be someone, but like why input is made smaller in the first case, right? Why input is made smaller? So, uh, okay, let's say that uh, we have one basically we have some question, right? Why my pen is lagging a bit? Yeah, we have some question, right? We have some question, and on conversion, basically on conversion, we make the input smaller, right? Why is that basically the case that if we make the input smaller, it is fast to solve any kind of problem. I'll give you one example for it, right? Let me just show that example as well. Yeah, so let's say that there's one like life, I mean real life. I will give you one real life uh, example, right? Let me just draw this. Fine. Okay. Let's say that you need to get a job, right? You need to get a good high paying job. Fine. You need to get get a high paying job, right? High pay job. I mean, this should not be the only motive in the life, but okay, let's just take that example because many of you guys right now will have the same, right? So let's say that this is some scale, okay? This is some scale, and this in x-axis you need to get high paying job, and in y-axis this is a difficulty level. Fine, this is difficulty level. Fine. Then the difficulty level is somewhere here, right? Now you do some things. Fine, you have to, like, let's say that in the here you are in 12th class. Fine, you are in 12th class, you need to get a good paying job, and difficulty right now is in this, in some value, right? Let's say y, right? In some value y. Fine, you do some things, right? In your 12th class you do some things, and you do some things, and then maybe this and then your graph can become like this. Your difficulty level basically, like, in life whenever you're growing, yeah, right, whenever you do some stuff, right, whenever you do some stuff, whenever you do D1 is some, you did some stuff, you're decreasing you're basically going closer to your goal, right? So your difficulty level is now decreased because you did some good stuff. You maybe good cracked, you learned some new skills, right? During your 12 to college transition, you maybe got into some good college, right, where placements are good, right? So now the difficulty will be small y, right? Let's say that small y. So basically what you did to do, you you did some things D1, and then your difficulty level like got decreased, and you got more closer to the goal. Now again, in your, let's say, third year, right, or let's say third or second year, right, you did more things, right, like learning a new, like learning more skills, getting polished more in DSA and all. Then your difficulty will be level will be very low, as in, like, you will most probably get good paying job if you play your cards well, right? So basically this is what recursion is. You do some things to make the problem easier, easier and easier. This thing, these D1, D2, this is what recursion is. Fine, this is what recursion is. So basically, what is D1 here? D1 here, D1 is D1, you can say that D1, D2, these are called decisions. You make some decisions so that your difficulty of the problem of your, basically your difficulty decreases, right? So here I can just say that D1 D1 is just let me just use my mouse. D1 D1 D2 are decisions that you take in life to be closer to your goal. This is what happens in recursion. Fine, this is what happens in recursion. In recursion, you, okay, I will just write one statement so that you guys can get the point, right? So basically, we don't make IP smaller. I mean, yeah, ultimately input smaller. I mean, input smaller. Ultimately, our like to make the problems more easier, we decrease the input space, right? But we usually don't see that first. We make decisions, right? So we make decisions, right, on which input automatically becomes smaller. Right, you can, if you need, if you want to correlate with this example, you can see that difficulties are can be the input, right? But you take the important thing here to consider is that you take some important decisions. Wait, someone just joined. Admit. Yeah. So you basically take some good decisions D1, D2, so that your problem becomes easier. So this is what recursion is. In recursion, you take some decisions and choices to make your problem more easier, right? So some keyways is that, like, focus. So focus on correct decision making. Fine. I mean, this class will be more of talking, more of explaining, like, what is the crux of the recursion, so that you can approach any problem, right? So we can see that, like, just focus on decision making, how you can make decisions in the uh, in this part of concept. So right, yeah. So basically now they I will discuss some more ways to like how you can approach any kind of question in recursion. So there basically are four ways, but for now we'll just start with the basic one, like recursion tree. If you guys have heard recursion tree, recur recursion tree. Fine, let's start with this. Fine. So basically what recursion tree is, that it's just set of decisions that you make, right? Now I will explain this. Like let's say that you have uh just hold on. Yeah, is it lagging now? No. Okay. Yeah, let's say that you have some problem statement, right? You you will make some decisions. Let's say that you have one statement, right? You make some decision, you need to make some decision, and then you again make some decision, and then you again make some things, and then you reach to some base case, and then you just return it. Basically this is what recursive tree is like. And then once you make recursion tree of any question, then you just need to code. And you're like, if you are able to make recursion tree for any kind of question, your 90% work is done already. Fine, because after this, writing code is like a piece of cake, right? So it's very easy, it's really easy. But you need to learn how to make recursion tree, or maybe how to reach to this step and then code. Like this is one of the ways which I will be discussing. There's another way which is called IBH method, which I will discuss later. But yeah, so recursion tree I will be taking for now, because we discussed like how by making decisions you are making problems easier, right? So we will be taking one example. It's very common example first, right? So that you guys are basically little bit familiar of recursion from start. Okay, so there's one problem of subset. I guess some maybe people have heard of this problem, subset, right? Let's say that you are given a b c in a string, right? You are given some string. Fine, now you need to return these things: one empty space, one A, one B, one C. Basically, all the combinations that you can think with ABC, individually or in pair, right? So B, C, and last A, B, C, right? Does anyone has any other type of combination with ABC which we can make? No, right? A, B, A, C. Pardon my writing. I don't know why my board is working a little bit weird today. But yeah. So basically we need to, make these kind of combinations. How we can apply recursive tree in here? I will just like, explain. But first, uh, let's say that okay, so let's again learn about what exactly we are doing here, right? So we have A, B, C, right? And you can see with the output, you can, whenever you see these types of questions, how you can say that this in this question you can use recursion. How? I will tell you that. Say, see, compare the input and output. See, like in input it is given a b c, and in output you are given some things, right? You can say that, okay, I have this thing, what I can do to get a, right? What you can do to get a? Basically you need to do something to get A, right? You need to do something to get AB, you need to do something to get AC, and so on, right? So basically what you are doing here, you are taking decisions to maybe not consider BC, right? What you are doing here, you are making, basically you are making some decisions to just consider A. Then here you are taking some consideration to you are taking decisions, like you took one decision D1, you got A. You did one decision D2, you got AB, right? AB, how you will get? You will not include C, let's say, right? And in D3, in decision 3, you want AC, right? So you won't consider B here in this case, right? So this is how, like, you're taking some decisions, right? And whenever you see this kind of pattern, just apply recursion. Fine. I mean, then you will know, like, you most probably you will be applying recursion. So I will just write another statement. Wait, someone just did admit. I'll just write another statement here, right? So if problem requires decision this decisions, oops, decisions, what happened, decisions to be made, right? So recursion will be applied, right? Will be applied. You can say that like another word can be like choices as well, like I said, right? Decisions or choices, right? So you can also say that decisions, yeah, choices. Like let's say that in this question also, in the subset question also, you are taking some choices, right? The choice to not include B and C, the choice to include not only B, the choice to include only C. These are all choices, right? So most probably recursion can be done, right? Because again correlate with this example which I told you, that as the difficulty increases, sorry, decreases. Why? Because you are taking some decisions to make your life easier, right? So in this question as well, you will take some decisions to basically get the required output, right? So that's how we know now that we can apply recursion in this question, in the subset problem, in this ABC uh, question, right? So how we will make the recursive tree, right? So I will just tell you one pattern. There are many patterns out there in internet, you can search them, but this is like what I understood. Like I also saw someone's pattern, and then I just got like, okay, this is good for me. So just have output and input, right? Okay, so in output there will be like, just consider some output, there's some output, and input you are getting A, B, C. Fine, this is the input. Let me uh the space a little bit. Yeah. Does anyone have any question till now? Like why, like regarding the recursion? You got the concept of how you can observe and you can identify, right? I will be explaining more
Yes, bro.
things. Yeah. So I will be explaining more things, but like for now, just is someone unmuted? Okay, yeah, cool. So yeah, so here how to make recursive tree, right? So it's basically very easy. Output, input, right? Right, fine. So in first case, we will be output is empty, input has ABC, right? So in first case, we will not be taking basically nothing in output, but here we will be taking the first element, right? So in this case, what will be the thing? Output will be empty, comma, and ABC, because we are not I mean BC, because we are not taking A, right? So we'll be just writing BC in input. We have just ignored A. We have taken one decision to ignore A, and in the here we will take decision to include A. So output will have something, and B, C will be there. Got it? This is the first basic step of recursive tree. Now again we will do same things. Same thing here. Same thing here. For every, basically what we are doing is that we are checking our input and like basically iterating, and then just checking that like taking decision basically to whether include or not include, right? So again here, let's like write in some other color, right? So here basically what you are again, not including, including, not including, including, what not including? B and B's, I'm talking about B's. So let's say that you don't include B, right? So what you will get, output will be empty, and you will get only C because you have just ignored B, right? But here, if you consider B, then you will have your output, and C will be here, right? In this case, you have not included B, so A will stay right there, but C will be there because you have ignored B. Here, you are considering B, right? So A, B will here, and C will be here. Fine. So this will be the recursive tree. But again, recursive tree does not stops like till your input gets empty, right? That's the base case which we will also be discussing. So let's say that again, uh, we can have two more decisions in each case, right? Let me just quickly write that, right? In each case, in this statement, I'm not writing input because input is empty because C. There's only one in element in inputs, right? So I will be just writing output. So whether to include or not include, right? We will be following this in everything. So uh, to include to not include, basically. Let's follow this, to not include, right? So what if we don't include nothing, we will have space. If we include, we will have C. If we include nothing, we will just have B. If we include B, C, again, what is there? A, right? So only A, this will be C, sorry. uh, if we include AC, if we include A, B, if we, sorry, not include, and lastly if we just include everything, A, B, C, then this. So you got the answer here, right? In the leaf nodes, you will get all the answers, right? All the combinations: space, C, B, B, A, AC, AB, and ABC, right? Got it? So this is how you will draw the recursive tree, right? This is one of the methods. Just I will just recap what I just did. So basically, what we had one problem, ABC, and we had A, B, C, these combinations. We first did identification, right? Identification. We first did identification, that whether we are taking some decisions or not. Yes, we are taking some decisions to make some things, right? So we found one way, recursive tree, right? And how we did, we have one output, we have one input string, output string, you can say. And then we just took decisions to whether include or not include. How we are iterating, we are just checking first. In our first call, we are checking first element of input, then next, basically we're popping, right? So next and third. So this is how we are making a recursive tree right here. Fine. And this is how you can, solve other problems. Like for now, you can solve other problems, as in the intuition you can solve till here, right? uh, excuse me. So our base case also, just don't forget, our base case would be, uh, base case is also very important for recursion, in recursion questions. So whenever input is empty, we get answer, right? Just like this base cases, basically whenever you got input as empty, just return, basically that's what it means, right? So this is what the recursive tree is, right? One more thing we will discuss now, right? So like, why we are discussing this again? Why, right? The question lies like, why recursion? Because recursion is everywhere. Fine, recursion is everywhere, and even as I told you that in interview questions, basically, you could have done this question using some other way of maybe iterating through, maybe using loops and all, right? So that would have been, repetitive, right? So in interviews also, like the interviewer might ask you to, optimize it more, use some better method to basically solve the problem, right? That's why recursion is like important, because we're using this, you can optimize any kind of problem, right? You can apply recursion anywhere if you have the guts, if you have the ability to apply it, you can apply it anywhere, right? And that's why I'm focusing more on approach, and how you can think to, like, where to apply recursion in this video, in this in today's class, right? So also, in recursion, there will be like in the future lectures as well, many lectures will be based on recursion only, right? Like dynamic programming will be based. We will be discussing backtracking, right? Backtracking is really important. So backtracking will be will basically, we will encounter recursion there as well, right? And also in the questions like divide and conquer, right? L- Divide and conquer, there also recursion is really important, right? So it can be used in many kind of data structures, basically in binary tree, linked list, in arrays and all, right? So it's really important, and important for interviews as well, right? So now we will be solving one question, basically using recursion, like proper code and all, right? So it's really basic question, but I just wanted to give you little bit of, crux of recursion, right? Hence I'm picking this question. Basically, you need to print 1 to n numbers, but using recursion, right? using recursion. It's really easy, but in this question, I just want to, like start introduce you to the different ways, right? So, basically in recursion, there are four approaches. There are four approaches to solve any kind of question, basically, right? We will be discussing only two today, but I like it's important for you to know, like there are more ways than two, right? First method would be what we call as recursive tree, right? Tree Recursive tree, yes, which we discussed. I mean, did not completely discuss. We will do one question at the end of recursive tree. Now, after that, we have a method called as IBH, or let me write the full one: induction, uh, base case hypothesis. IBH, right? This is what IBH is, and then we have another method which we will not be discussing today, but it's dynamic programming. Fine. And there will be one more method which will be taken soon. Fine. I won't be telling you right now. It will be taken soon. Coming soon, basically. Right. So there will be four methods to solve any kind of question which has recursion. Right. We will be discussing today these two. These two will be discussed in future classes. Right. So these two methods. Fine. We will be basically discussing like recursive tree. For now basics are done. Now we will take IBH method, right? So IBH method. IBH method, fine. So basically, let's start from what exactly, like, we know what base condition is, right? base condition Base condition basically makes, like, we go to smallest input, right? Smallest input. You can also imagine base case as like, okay, let's say that we have some uh, one scale, right? What exactly a base case is, right? Like, in even in Fibonacci series, whenever you write that code in recursion, you say that, right? If n is equal to 1, if n is equal to 1, right? When n becomes small, n becomes 1, just return, right? Just return. So, and you have one number n here, right? So you basically, these have some valid, inputs, right? Let me write in this color. These have some valid input, right? Like, till here, till 1, you have valid inputs. So basically, what we are in base case, what we write, we go to we go to smallest valid input, right? Also, you can write base condition as, okay, like, before 1 or before 0, all, if, like, n can never come here, right? Because these all are invalid inputs, right? In, let's say, in Fibonacci series only, these all are invalid, right? So in base case can be written, if we consider the largest if we considered the let me write in this way: if we also consider largest invalid input. Got it? Like, in base condition can be, also, let me write, can be smallest valid input, right? Can be smallest valid input, or can be largest invalid input, right? Smallest valid and largest invalid input, right? So this is what base condition is formed, right? So, like, this is basically what you need to understand. Now, hypothesis. What exactly is hypothesis? Hypothesis. Oh, sorry. Hypothesis can be, like, we basically do hypothesis so that we can have, one solution. like one basic solution for any kind of question, and then we do induction. I guess this you will get when I will be explaining you the, like when I will be doing the problem, right? So just right, like we do uh, we do this to so that we do this so that we have one solvable one solution, one solution pattern, right? One solution pattern, right? Like in this question, let's say in this print 1 to n numbers, print 1 to n numbers, hypothesis, like I will just also write hypothesis in this question would be it will print 1 to n. Basically there will be I will start doing the question, right? Because this will be get confusing. So okay, let's start again. Let's start like print 1 to n. Let's break this problem, right? It's really basic problem, but let's just get more deep into this, right? So let's say that we have some we have input, we have one input, and we have one output as well, right? So uh, and these are give, and like let's say that we have 5 in input, we have 5 in input. What will be the output? Easy, 1 2 3 4 and 5, right? No doubts in this, right? No doubts in this. Let's say that we have some value n, right? Just focus on this question, because this thing, okay? So we have n. What will be the output? 1 2 3 till some n, whatever n is given, right? Whatever n is given, fine. This is what basically what the question wants us to do. So in IBH method, like applying IBH, right? Like for identification, I mean, this question is basically have some pattern of, you know, input and output have some pattern. I mean, this just has recursion, right? So there's not much thinking or identification required here. So just apply IBH right now, right? How we will apply IBH? Let me tell you. So first we will be doing hypothesis. Like first step will be hypothesis, not base case. First we'll apply hypothesis, then we will see. Fine. Uh, okay. Let's say that we have one. We have to make one print function, right? And we have one input as 5, right? 5. This, if we make print 5 function, this should give us 1 2 3 4 5, right? Right, yeah. Now as I told you that we kinda make input smaller here, so basically in IBH method also this is some kind of pattern to make input smaller, right? Like we can say, what if I write 4, right? What output should this give? 1 2 3 4. That's all, right? Right. And let's say that I have basically I have similarly I have print n. We have print n, and we write also n minus 1, right? This will give what? 1 2 3 4 till n, right? Let me write this, right? What will this give? 1 2 3 4 till what? N minus 1. Got it? So So basically, this is what our hypothesis is, to make print n function, and we basically have to figure out how you can break it into smaller function. Basically, in hypothesis, what we do is that we break, or we make input smaller. So also this making input smaller will not be in decision tree, in recursion tree, because that's totally different. This will be applied in IBH method, right? Whenever you want to apply IBH method, when you want to apply IBH method, then you will be approaching like this, like hypothesis. You will try to make input smaller by one step. Fine, just why one step? For now, just like why we are doing one step, because that's the only pattern, right? I don't have any other answer for this, but just like for your understanding, just think that we need to make input smaller, right? And the smallest, like we can't be like n minus 5 because we don't know some uh, we don't know n, right? N can be 2, we can't say n minus 5, right? We need to make input smaller by only one factor, and that's how we'll be writing our base case as well, right? So just let's just say that we have n minus 1. So our job is to see how we can make print n, right? Print n. So do you all agree that if we find how to make print n, we can find print n minus 1 as well, right? Let's see how. Let's see how. Fine. Let's say that we got how to make print n, right? Now our next step would be induction. In induction, this only makes our code to run. Fine. Basically, if we figure out what exactly we are here doing, let's say that we know that we need to print n, but we found that we can make the input smaller and print numbers till n minus 1. Fine. If we do this, just go to induction step, and in the induction step, you basically have to be solve the whole problem, right? Okay. Let me give one example. Okay. You have 1 2 3 4, right? You have print 5. 1 2 3 4 5. Fine. So you don't know how to make them print 1 2 3 4 5, right? And in our hypothesis step, you did n minus 1, which means 4. You got how to print 1 2 3 4. Fine. Now our required output was this, but we got our input, like our current output, like this. So what we need to do to make this output this? Can someone unmute and tell what we need to do here? Anyone has any idea? Like, what is the difference between print 4 and print 5? Can someone tell that?
Just a value.
Yeah, just a
You
value
add up.
5, right? Right, yeah, exactly. So, if we know how to write print 4, right? Let's say we know how to write print 4, print 4. Can't we just see out another value as 5? Basically, what I did here is that I said I know how to write print to 1 2 3 4, but after that I don't know to, basically we need this output, right? So I will manually just insert the last element as well, 5, which is basically n. So we got the solution. Got it? It's very easy because in induction what we do is that, okay, like revising hypothesis, we make the smaller input and we just see the pattern. Basically, if you know how to print n minus 1, you can basically print n as well. Why? Because you just need to add the last n, which will be basically c out n only. Right? This is what induction means. And coming to base case, let's also find out our base case, right? Base condition or base case. uh, Base condition, let's say. Base condition, fine. What will be our base case? If n is equal to 1, what should be the printed? Only 1, right? We should just return 1. That's, I think, very self-explanatory. And if you want to visualize this in a graph, as in the in xy axis, which I told, right? So like, let's say this will be 0, this is some n, right? And we have our 1, right? Print 0 is invalid, right? Print 0, you can't say print 0 because that's invalid, right? So this will be invalid, like minus 1 we are not considering for now. Print 0 to 1, if the value is here, let's say we are not considering it, fine. And print 1, so this is what smallest input, right? Smallest input, we see, okay, this is the smallest input, hence we make this our base case. If n is equal to 1, return 1. That's our base condition. Got it? Is everyone clear with this idea? We will be writing code after this of print n minus 1, print 2 1 to n numbers, right? So this is what pattern is. First you do hypothesis, you make the input smaller, then you see how you can, basically how you can match your current input to required, sorry, current output to required output. Okay, let me just write here as well, right? Here you see how to make your current output equal to required output. Fine. So this is what induction is. Hypothesis, make input smaller. Induction, like try to make your required output to current input match those, and then base condition, which I told you how to check. Right? These are the steps. IBH method. Fine. Now we'll be writing a basic code. It's very easy, right? So what we need to do, like let's say that uh, we have one function void print right, which takes n number, which takes some n number, right? What's like we will start from base condition. What's the base condition here? If n is equal to 1, what? Just return 1. That's our base condition, right? Now we will be seeing that how you can basically make, I mean, we will be doing our hypothesis, right? So what was our hypothesis step? We do n minus 1, right? We are calling function inside function, that's recursion, right? We are doing n minus 1, and with n minus 1, let's say that our this, like we inputted 5 with n minus 1. What is our output? Can someone unmute and tell? Like I have inserted 5,
4,
so
sir.
basically no, like 1 2 3 4, right?
Oh, okay.
This will basically just assume that print n minus 1 gives you this output, right? Okay, let me just explain that once more. Let's say we have print n. You just have to basically just assume that print n prints out 1 2 3 4 to l. Then you say n minus 1, that will output till n minus 1, right? So here n minus 1 will give you n 1 2 3 4, right? Now, now what you need to do here to add 5 again? Simple, just see out n as well. Again, this is just an example, hence this might seem like very direct and not I mean not having any pattern, but this is what basically you can just also add one space here if you want, and just you don't, you just stop, right? So this is what our recursive print n 1 to n numbers will look like, right? And again, now coming to another thing, what if we need to say that print n to 1 numbers? Can someone now just take 5 minutes and try, like just following this pattern, like exactly what this I told, this pattern to get this code? Can someone just try? Take 5 minutes, right? Let's have 5 minutes pause. Just okay, I will just revise. You also try this, right? Your question is to print n to 1 numbers, right? So what you can do here is that you can do hypothesis, right? You can, make the input smaller, right? Then use induction to match your output. Basically you can do some things to match your output, and then you can write your base condition, and then which will be I guess similar only, right? Yeah, it will be very similar, and then just write the code. Can you all try once? It's really easy. It just, you need to, and it's basically very similar to this code. You just need to do one thing. Fine. Can everyone try that? I will give you like 5 minutes or 3 minutes, I guess. This doesn't take, should not take more than 2 minutes, but just try. Fine. You can write your code in chat as well, right? But using my method for now, because that's what I discussed, right? So print n to 1 numbers using recursion, right? Try to solve this. Yeah. No one tried it. It's very easy actually. Let's say, okay, again I will be doing similar step. Fine. Uh, what? Yeah. So we, like let's say that we have one print n. Fine. We have one print n, which basically gives you some output, which what we need, n till n to 1, right? n n minus 1, n minus 2, it will build to 1, right? Now what if I write n minus 1? what output should this give? Easy, right? N minus 1, it should give me n minus 1, n minus 2 till 1. Simple, right? I don't think there's much to think here. But like what you did in hypothesis, we are making input smaller, right? So n minus 1, n minus 2, 1. We know n has to be like this. So we thought that okay, let's make input smaller. Then what should be this input? Sorry, our output n minus 1, because we are basically making this, we are considering for n minus 1. So this will be input, the output will be in this way, right? Now next comes our basically what our induction, right? We need to match them, but I can just write code right directly here because we just discussed that. It's exactly really easy. Let me just see, tell you guys. Let's say that we have print n minus, we have print n, right? Similar base case, because if we have only one, just return, right? Um or just return one, right? Because there's no point. And then you need to, okay, if you call here print n minus 1, okay, what will be the answer for this one? Let's say that we have 5 here, we have inputted 5. What will be the answer for this? Can someone tell? And you know that by printing n, you will get you need to basically, oops, not this, you basically need to get the output as 5 4 3 2 1. You know, basically let's say that you know that print n will give me output in this way. So what will print n minus 1 give me the output? Can someone unmute and tell?
4321.
Yes, good. 4 3 2 1. Now in the next step, or what you can do in this to add 5 here, this is what induction is, right? It's really easy. You have to see out 10
We
somewhere.
can
You
insert
can, yeah, go on.
before we can insert 5 before
Exactly,
4.
exactly. That's right. And you just did induction and then, yeah, done. Your 3 steps done. This is what the code is. This is exactly the code is. You just need to do this. Got it? Basically, you are just in induction. My whole point, I mean, you won't get, I will see, the induction step won't be this much direct in the questions which we will do, right? Like, just you need to see out and then done, your question is done. No, that's not the point of this question. The point which I wanted to tell is that how you can basically use hypothesis, how you can use induction. What exactly I wanted to explain you what induction is. That's why I took this example. So induction, basically, like, you need to make the input smaller in a hypothesis. In induction, you can just find a way to make your current output equal to required output. This is what induction is basically. Got it? And then base condition, I guess it's very self-explanatory. I have explained here. Fine. So this is what I wanted to tell. This is like, okay, the only complex step which will be in this recursion, in this IBH method, would be to figure out how the induction will work, because I guess base condition you will see the pattern. Induction, sorry, hypothesis is just small, making one input small, nothing much in that. And then induction, you just need to figure out how you can make your current output to equal to required output. That's what the point is. Got it? Now, yeah. So now we will do one question which requires little bit
Bro,
of thinking. Yeah. Anyone has any
bro,
doubt? Yeah.
ah, yes, bro. In this, the second question from print n to one numbers. So we'll be C outing n for each iteration, isn't it?
There's no,
For each recursion.
yeah. There's not
Oh,
as like we can say that it won't be in this way. Basically, it will be. It's not in a kind of loop, right? So this will just input that. Uh, okay, your question was that, right? If we basically, if we make n minus 1, if we like, if I say 5, right? So it will again print 5 and then 4 and then 3, 2, 1, right? Then again it will print 3, right? Yeah, I got your point. Yeah. So basically, you're saying
yes,
that
yes, bro.
if I see out here, right, it will just interrupt the whole flow. Yeah, your point is right actually. Uh, so you
You
can
can
make one
print at
check.
5 even before the loop, right? Like before
Exactly.
the void also you can do that.
Yeah,
Then you can
you
do
can
that.
basically print outside that as well. I mean, but
Yeah, and then you can just let the loop.
in these questions, basically you need to figure out the function here, right? So in induction function, basically, again, this was just an example, so it won't be as direct as I told that you just need to print out cout 10. No, there will be, you need to make another function basically, and then that function will be called only when this loop works in the last condition. I will explain that in the, we will do one more question. Basically in this, okay, in this one you can just print outside the function as well, but in our next question, you will see like how we can form another function here, right? I will explain that as well. Fine. But for now, the whole point, again, the whole point was not to, solve the question, because it's not nothing, it's, there's nothing. The point was how, like, what exactly induction means, right? So this is what will be the point. Okay, so let's do one question. Sort an array using recursion. Again, this might be very direct, but let's say let's say sort an array using recursion. Fine. So we will be doing this. We can use, again, for sorting array, you guys can use a sort function and all, but like for now this is recursion we are talking about, so you can also do merge sort as well using recursion, but we will be doing little, uh, you will be following IBH method here, right? So I just want to explain you this IBH method. Otherwise, it's your choice to do this question anyway. Fine. So first we will see like how to identify how to identify um, basically what exactly you're doing in this question, right? So let's say I will just give you one example as well. Let's say that in this sort function, you got some, you got 1 2 3 1 5 4, basically you got this, right? Your output should be what, 1 2 3 4 5, basically, right? Yeah. So your so how to identify that this can be done in recursion? Okay, let's say that this is just given that you need to sort an array, and you need to identify how to, basically, how you can apply recursion here, right? So I will just again write one example here. If you can take decision, you can apply recursive tree, basically, right? Else I will just, like, if you can take decision, that's another thing. Apply, okay, I will just write apply recursive tree, maybe, right? I mean, this is just my thought process which is going right now. So I'm just writing my statements here. So let's say if you can take decisions, apply recursive tree. If not, else, then we can, make input smaller, basically our IBH method. So, right, yeah. So this will be, so basically when we also discuss the recursive tree in the last question, this is our primary method here. Fine, primary, and this IBH method is a secondary. Like, always going with decisions this way is good, is much better, like as per the requirements, but we can go with input smaller IBH method as well, right? Here I will be discussing IBH method. So um, so you can also make a note, like with this you can also make a note of this thing which we are discussing right now today, right? I'll so let's say recursive, we have one recursive problem, right? And we are basically using two methods here to solve. Let me just, you are we are using two methods here to solve this question, right? One method is decisions, where basically we make recursive tree, right? Like this. What happened to this board? Yeah, like this, right? And in our next second method, we basically have three steps IBH method, right? Let me also, like in this form, this is for your note reference, right? That's why I'm writing this. Otherwise, I have explained this, right? Um your this is a recursive tree, recursive tree method, or else you can use IBH method. IBH method, which requires what? Which requires three steps basically. What are those three steps? Let me just write them. Yeah, so first step is you need to create hypothesis, right? You need to create then induction, not base condition. You need to think of base condition as well, and then finally you can do induction here. So these are the two methods which we will be dealing, right? Recursive tree I little bit discussed with you guys, and IBH method I will be doing right now. Fine, this is just for your note reference. Right. Now, what was the question? We need to sort the array, right? So, starting with our first step, we need to sort first. Like whenever you see these types of questions, just first of all, just visualize what you're doing, right? Like let's say that we have 2, 3, 7, 6, 4, 5, and 9, right? You have some numbers, sort 2, 3, 4, 5, 6, 7, 9, right? Uh, Now, we do hypothesis, right? We can kind of make some function. Again, we can make one sort function, but we can make the input smaller, right? How? Let's say we can, okay, let's say that this gives us what? If we have this array in this function, right, in this sort function, what will be the output of this? Easy, right? It will be 2, 3, 4, 5,
4, 5,
6, 7,
6,
and 9,
9.
right? 1 2 3 4 5 6 7 1 2 3, yeah, it is yeah. Now let's say that in another we are making input smaller basically. So let's say that we kind of like removed 9, let's say, okay, we removed 9. Now what will be the, an input will be 2 3 7 6 4 5, right? So what will be the output of this? It will be 2 3
2,
4
3,
5 6 7.
4, 5, 6, 7.
That's all, right? So basically this is what our hypothesis is, like for till now, that if we remove this we will get somewhat this question, this thing, and we will see, like this is what hypothesis is. This is what, like, for a beginner in recursive, in in like, well, he or she is sorting and numbers arrays, this is what basically the thinking process should be. Or we can think anything, but this is what I'm thinking for now, right? So now let's say that we also see kind of base case as well here, base condition, let's say. Fine. Okay, so what can be the base case here? Let's say that you again reduce it to -1. You again, your loops, basically your function is called every time. So again, -1. Basically, you're removing element. In the last, you will get one sort function which will have only one element, right? So this is what our base condition would be. Sort 2, can you sort 2? Basically what you will do with one element, if there's only one element you can't do anything, right? You can just return it as 2, because there's nothing to sort, right? You need to, you don't have anything to compare here, right? So you can say that again, you can visualize the, you can visualize this plane 0, and you have this some n numbers, size of array, and you have n minus 1 here, right? And then, and our base condition would be again, if the element is at 1, like if the input is 1, then just stop. So this will be invalid, and this will be valid. So basically your base condition would be kinda this, right? So if you can also write, if array dot length is equal to 1, then just return, right? You don't have to do anything, right? So basically, the if the this is the number of elements here, that's why array dot length. Fine. So this is what your base condition would be. Cool. Now we will discuss what induction. We'll discuss induction here. How you can now with this step only, like even now even you can see that hypothesis is kind of done here, and base condition is also visualized here. So these two steps are very basic and easy. The main thinking part comes when we are dealing with induction here. Fine, this is what basically induction uh, makes us do. So yeah, so let's say that we have let's take some smaller example, 1502. Fine, we have one sort function which has 1502. Fine, this will give us our output as what? 0, wait, control Z, let me write it. This will give us as 0, 1, uh, 2 and 5, right? This will give us as this. Let's say that now we have another. Now we are reducing it, right? Sort 150, right? What will this give us? This will give us, let me write it, 0, 1, 5, right? This will give us 1 5. Now our what our induction was to make our current output equal to required output. This was our required output, this is our required output, and this is our current output. What we can do to insert our 2 back to this array in a sorted way also, right? Because 2 is in between, you can see 2 is not like you can't just add 2 here or here at the end. You can't do that, right? So you need to find some way to make 2 back into this array in a sorted way. What you can do here, you can maybe you can what you can do here is that maybe you can have one more, let's say vector. If you are dealing with CPP, right, and you have one I pointer and you have one I and one some j pointer, right? And you can check like if 0 is bigger than 2, uh, no, so insert 0. If is 1 bigger than 2, no, insert here. Is 5 bigger than 2? Yes, then don't insert 5, then insert 2. And if 5, and then after at the end, if there's nothing here, just return the last element. So you will get this array, right? But this is again not recursion, right? Because you are using a loop. In recursion, you don't need to use loops again, right? So this is one way, this is one brute force method, but we will be thinking how to apply recursion here again to basically make this to inside this, right? So this really interesting thing happened here. You got one more new problem here, right? Like you can basically, if you can use this method basically to create, but this will create an extra space because you're using another array, right? So you need to make it more optimized, right? So we will be going with, like, first method was this, we'll going with recursion to in this part as well, like how to insert 2 back to this 015, right? That will be our new problem. Basically we got our new problem, right? So uh, let's discuss this new problem now, and then we will get back to that question. Fine. So is anyone having any doubt till this step? Because then this will be, you'll be
No,
lost.
bro.
No. Okay, cool. So uh, okay, so we have one new question here, right? You have 0, you have 1, you have 5, right? Just hold on, let me fix my uh, tablet. Is it any better? Yeah. Okay, so let's say that you have 0, you have 1, you have 5. Fine, you have this, and you need to get this to somehow basically here, but using recursion, right? So we in this question we like we basically what we do in recursion, we make hypothesis, right? We in hypothesis what we do, we make our input smaller basically, right? So can't we just ignore this element first, right? We okay, let me say, that we have one function here. Okay, let me write it here in this way, right? We have one function insert, fine, which takes an array or vector, I don't know, and one temp variable. In this case, the temp is 2, right? And this gives us, this will basically solve our problem. I mean, this will give us 0, 1, 2, 5, let's say. Fine, this is what our hypothesis is. Now, can't in hypothesis, what we do is that we ignore, basically, we make our input smaller, right? So, after making it smaller, what will be the way? It will be 0, 1. We are basically not, uh, we are ignoring 5, right? So, 2 here, and we have just ignored 5. We have just, maybe, we have separated it somewhere, right? We have separated it somewhere. Now you can just add 2 here, right? You can maybe add 2 here, fine. And uh, maybe then you can again, let's say that after this step you got 0, 1, 2, right? And then, like, after the step you got 0, 1, 2, and then that 5 which was somewhere stored, basically you don't, you just stored here, you can just again fit back to here, to back to 5. So you will get 0, 1, 2, 5, right? This is what our pattern is. Now you may be thinking, what if this 2 was not there, let's say that it was 6, right? Then we can't enter, like if we just enter it 0, 1, it will become 0, 1, 6, and then 5. That should not be the case, right? So we need to handle that case as well. Fine, we need to check if 2 is bigger or smaller than 5, or uh, I mean the number which is ignored, or which is stored somewhere, right? So we will be dealing with that case as well. Fine, how will we dealing with, let's see let's say that our base condition in this case, fine, our base
If it is
condition,
6, can't we just directly like print it after that whole array, like see out you told, right?
but
At the
you
end.
need to see that 6, you can't be, okay, see, like 6 can be any number, right?
It'll anyway be 0, 1, 2, 5, 6, right? So you can print it at the end.
0, 1, 2, 5, 6. Oh no, you got confused basically. 0, 1, 2, 5, that's the our original case. 6, I just took an example. Like, what if basically uh, in our case, wait, what I did, what if our 2, like in place of 2, what if there was 6, right? I was talking about that case. Like in this our in our example, I have written in this way, right? That 2, 3, like in this case, 2, 3, it starts from 2, right? What if there was some number, weird number 6 here, or some other bigger number, and then you have ignored? So you can't basically rely that key the first number would be smallest one, right? Hence I have considered that as well. Like, what if we have like, just forget this example. We are coding for a generic example, right? Let's say that we have some array, we have some another element which we have, removed, right, for our induction to work. So, what if this number was bigger than what we will remove again? That's my consideration right now. Like, what if it was 6? Fine, we have to consider both the cases, because the array can be anything, right? That's why I'm using this, that's why I'm considering this. So let's say that we have one base case, we are discussing some base case. Fine, we have base case. What can be the base case? Again, if the v dot, okay, let me, if, let's say that if I'm using vectors, let's say this is some vector, okay? So if the v size, vector size, or array size, you can do anything, if the v size is 0, right? or 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 v v dot size, just hold on, I will explain, -1 is smaller or equal to temp, what you should do, you can just add or push back the temp. Okay, let me explain as well. Enter. So here, if the v size is 0, basically if this vector size is 0, right, you just need to push 2, right, because if there's nothing in this, right, this is the base condition basically. Like when we are removing 5, then in next in the next recursive call we are removing 1, and there's nothing left here in this array, right, we can just push our temp here, right, that will be the case, right. Or or here I have written, if v dot size minus 1, basically vector size is 3, and the indexed value 0 1 2, if this value, if this 5, right, if this 5 is smaller or equal to temp, as in this is stored in temp, this was temp, this is our temp, right, then just push 2. Like, let's say that if 5 is, like, let's say that our temp was 6, right, and this is bigger than 5, then just push in this 6 array. Got this point? uh, Someone asked that why we are considering this, why we can't just add 6 ahead, right?
Yeah,
Now
yeah,
you
yeah,
got
yeah,
the
yeah.
question,
Got it.
now you got the thing,
Yes,
right?
yes.
We need to think in algorithmic way. That's why that print 1 to n numbers, I told you that that's not how we will solve the question, that printing it just before it, because that's not the way. We will be considering cases like this. Has anyone have any doubt in this, why I have written base case, right, like this? This will come with practice. Again, this you won't be, maybe you won't be able to crack this very fast, but as you solve the problems like this, you will get that the point, because what we are doing here is that we are doing the same thing again and again, basically, right? Recursion, hypothesis again, right? So yeah, this is what basically what I meant, that we will be using this will be our base case. Fine, very easy. Now we will be writing insert function, basically our this function, basically, right? That how you can basically this function how you can add this to in this using recursion, right? So I will be using void because this does not uh, return anything. This will be just making this. So let's say that uh, we have insert vector v, we have some vector v, and we have also int temp, basically, right? Our base condition would be this, our base condition would be this, right? This will be our base condition. Else, after that, uh, okay, let's say that base condition you write, okay, let's say that we need to basically what we have to do. Okay, let me also write that here. We have 0, we have 1, we have 5, and we have 2 here, right? It will check, this statement will check if this is bigger or this array is empty. No, then it will go to this step. Now we need to remove this 5, basically, right? We need to store it somewhere. So let's say that we store it somewhere, int val, right? And we have int val v dot size minus 1, basically. This will make the 5 someone, like, we have val, this will store 5, right? Because if this is a size and this is the last element, and then we need to pop it out, right? We need to remove, so we can also write we need to write v dot pop. If you are using array, you can use a similar function. We pop back, basically. Then you when I write v pop back, you can make your array will become 0 1, basically. Your array will become, after this step, your array will become 0 1, and 2 will be still somewhere, and 5 will be here, val, stored at val. Got it? Now you need to run insert again with v, new v, and temp. Now also I forgot, this will be and you need to pass vector or array with like reference with v, because let's say that if we would have passed v here, then if you had used insert v, then it would take the original v, not the modified v. So you need to pass the vector as reference here. Fine, so please note this point. You need to pass the vector as reference here, and then if you do this insert v temp, it will consider this case 0 1, and then it will do the same thing. Insert v temp will call back this, it will do the same thing here. Then at some point the 0 will also go. Some point it will okay, no, after this point only it will see that if it will call this one like 1 1 is smaller than 2, right? So it will directly push the 2 here, right? You are you guys able to visualize this? Right, it will directly push 2, and then the value which was stored here 5, what we can do, like after this step we got our array as 0 1 2, and 5 is stored somewhere at val. What we can do here to push back to 5 here in v can just push back basically, right? We can just, after this step, we can just write push back what val. Done. Your question, your insert function is done. Simple. Is everyone clear with this, or should I explain it again? You guys can write or maybe tell, because this is really important step to understand. Got this, everyone? Okay, I will just explain it again. So let's say that we had 0, our problem was 0 1 5 2. Fine. Our problem was basically how we can make this 2 insert in a way that our required, it matches with our required output 0 1 2 5 basically, right? So what we did, is that we made insert function. We we made a check that if this array is empty, just push 2, or if this the number which is at the last, right, in the last of the vector or array, then just if the number is smaller than the temp which is stored here, just push temp directly here, so that, like, let's say we have 6 which is bigger than 5, just push it back in the vector, you'll get the required output. Fine. And then we called insert v temp again, and then the 5 which was stored here somewhere, after the operation we just pushed it back to our value. Got this? Is everyone clear here? Also I have to write return here because or it's a void function, so that's not required. Got this? Is everyone clear with this? It's really easy. Now again, coming back to our summing up the question, the whole question. This was not the question, this is the part of the sub problem, right? Our main question was to sort an array, right? So let's again quickly sum up everything. So we had some sort function, uh, basically 0 1 0 1 5 2, right? We had some sort function, right, this which gives us 0 1 2 5, right? Now what we did, we can make our sort function remove the first element here, right? We can remove our first element here, and we can say 0 1 5. What will this give? Oh wait, just hold on. Yeah, okay. So what will this give? This will give 0 1 5 basically. It will just give this thing, right? Now we need to call our induction to make this to insert back here, and for this we made our insert function which takes this array and this temp. It's So what we did here is that we are, like, just to insert this 2 back to this array, we are calling one insert function. We have made one function which takes this array or vector and this temp. This is stored in somewhere temp, right? And then this is done. This will return you the 0 1 2 5, and yeah, this will just return the answer. Basically this is what we did, right? So you can summarize, you can basically write this thing. that we had one sort function, right, using which we did we made insert, and then we dot push we dot push back, which I will be telling you, right. So this step was called, this is induction. This is basically induction for our sort. This insert for making the sort, making the induction of sort, we made insert. For making the induction of insert, we did this. So basically we are calling induction and induction, we we push back, right. So this is what we did for insert, right. Got it. So I will be writing full code now, right, from the start, so that you guys can visualize it. So I will be writing here. Okay, so quickly I will write void void sort. We have one vector int, which takes just and also we will be passing this by a reference. Fine, please note this point, they're really important, or else your code won't work, right. So if v dot size, right, if v dot size is equal to 1, there's nothing to sort, right. So just return. Fine. If int temp, now we need to basically in this step, in the next step, what we are doing is that if we are given an array, we are basically just doing the hypothesis, right. We are just removing this first one element here, right. So in temp we will be doing what, we will be storing our some number, right, which will be our first number. So v dot size minus 1, basically because it starts from 0, right. So in this, like, let's say in this our first example, basically here 2 3 4 5 6 7, we when we are doing the induction method, we removed our 9 hypothesis, we removed 9, right, and we need to store it somewhere, right. So 0 1 5, I took some other example, but it's the same thing basically. So I have stored it somewhere in 5 in temp, right. Now I can pop back, basically I can pop back that temporary, right, and then call the sort function again, right, call the sort function again, and then perform this insert v temp. Got it. Basically when we are calling sort, it is giving me some number which like 2 3 something something till some 8, and the temp which we stored 9, this should be passed, these two arrays should be passed to make them insert, right, to make the 9 insert back. This should be passed in insert function which we just made, right. So that's why I'm calling this insert. And now for this, and again insert, I can call insert, I can make insert function which takes uh, vector int, which takes an vector int v, right, and also in temp, this is comma, yeah, right. So I guess this I discussed. This I think I discussed. So I will just copy paste here so that you guys have full code. No point of writing it again and again, right? Uh, so this is our full code for sorting an array using recursion. Got it? We have sort function which takes one vector, we check if the vector has only one, then just return, else you store the last element of the vector in temp, then pop back, then pop the that element, right. We are storing it so that we can add it later in the insert function, and then insert function I discussed with you guys, right. So is everyone clear with this question, sorting an array? Got it. So so this is what our sorting an array was, how we sort using recursion. Fine. After this I will have like one more question, It's very similar, but I will be giving you this as a homework and then we will discuss another question. But this is one homework for you guys. You need to sort a stack basically. Right, you need to sort a stack. Let's say that you have one you have one stack, right, which has 1 4 6 3 2. You need to did someone join right now? Admit. Yeah. So you need to sort this stack, but now you can what your brute force method can be is that you can make another stack, right? And just pop this here and compare, right? Like you can just basically use one another stack and do the do some questions. Sorry, do this operation. But you can't use one stack again. You don't need to use one stack. You need to perform recursion to make this stack sorted, as in like 1, 2, 3, 4, 6. Basically, this is your homework. Fine. Sort a stack using recursion. Let me write that as well. Very similar basically, but it's just that you need to replace the functions which I use in array with respect to stack. Simple. So using recursion. If you don't, if you have any doubt, again use our Telegram channel. If you have still, yeah, if you didn't get the answer or all, just discuss that in the Telegram channel, and yeah, you will get the answer, or maybe I will make another video of it. Fine. So this is what sort using a recursion. Uh, Now, we will be doing something somewhat called as reverse a stack. Like there are many other questions which will be giving you assignment, as in like you need to basically make subsets, permutation using recursion. That's very basic questions. I wanted to do something different, hence I am picking some different types of questions, right? Which requires little different thinking. So reversing a stack. So you guys want any break of 5 minutes? That's also cool. Yeah, is everyone here?
Yes.
Yeah, so we'll be starting with reversing a stack, right? So, yeah, so uh, basically, what the problem means is, let me just, yeah, why is not working? Hold on. Yeah, so let's say that we have one stack basically, and what we need is that we need to basically, like let's say this is given 1 2 3 4 5, and then it's in a sorted way, or actually we need to reverse, so it can be in any way. We need to basically reverse a stack. So let's say that this is our input, right? This is our input. Our output should be, right, 1 2 3 4 and 5, right? Now one brute force method, very easy, can be just use another stack and then return that stack. Like you need to pop this and push this, right? Basically that's what we need to do, right? But again, you can't use extra space, so let me modify the problem. uh, Reverse a stack without using another stack. So no extra space, no extra space. That's your constraint. So you can't use another stack and then maybe push back, right? So how you can do this? How you can we will use uh, recursion IBH method. Fine. uh, so IBH method, yeah. So first step, which we know, which will be hypothesis. We will see how we can write hypothesis of this case. Fine. uh, yeah. So what we can do is that, let's say that we have one function, reverse, right? Reverse, and let's say that this has some input. This has one input, which is, let me also write it. One, wait. this is some function which has these numbers, right? Yeah. um, yeah, so this will give us what this should give us 1 2 wait, control Z. This will give us 1 2 3 4 5, right? Let's say that we have one reverse function which we know that it gives me directly the answer. Fine. Now in a hypothesis, what we do? Smaller input, right? We can make our this 5 to go, right? To just ignore. So we can have one more function. We will have another call, right? Uh, which will be in this way. Let's say reverse. I have put this in stack, and this will be 4. Only these elements we would basically we have removed 5 here, and then what this should return me, this should return me this. Quickly let me just write this. Control A. Yeah, 1 2 3 4. This should return me 1 2 3 4. Fine. So this is what our reverse will be. This is our hypothesis, right? That we have made the input smaller, we have ignored 5, and then we can say this, right? So we have stored somewhere, again we have stored somewhere 5. Fine. So now our basically hypothesis is done. Let's see our induction, which is our main step basically, right? So induction, what this will deal, basically we can this is I mean what induction is what induction means here is that we need to insert 5 back in such a way that our input match our current in output matches with our required output. Basically we need to add 5 beneath the stack. So again you can have, this is a new problem of recursion. You can use one method to basically it remove everything and then push back this 5, and then again adding all the 1 2 3 4 back, but that will take more time and maybe extra space, right? So we will be using recursion, right? So this is another problem. So our main problem, again our problem is this. Now our problem has been uh, changed. This is our problem. I am writing in little this way so that you guys can basically understand it better. So our problem is basically this key. We need to add this. Let me erase this. We need to we need to add this 5. Add 5 such that our input becomes sorry, our output becomes this. This is our new problem in induction basically. So this is a new recursive problem. So we will be doing hypothesis again for this sub problem, right? So again hypothesis, let's see hypothesis, how we can write, right? Hypothesis of this thing. uh, what we can do, we can make another insert function, right? We can make insert function which basically takes this. Control CV. Oh wait, this is actually 1 2 3 4 5, because this has been reversed after induction is called. Like after this has been done, this step is done, then this induction is taking place, right? So 1 2 3 4, we need to add this, right? So insert, we will be control C, control V. We will make one insert function which basically takes array, and it also takes one element stored as 5. And what it gives us, what this should gives us, this should give us this thing, this should give us this thing. Got it? This is what our insert function is, right? Now making in hypothesis, what we do, we make our we make our input smaller, right? So we can maybe ignore 1 in this case, right? It's very similar to the sort function, but again the pattern is same. You guys can see the pattern is exactly same, and this type of question only you will get, right? So 1 2 3 4 5, 1 is removed. Fine, 1 is removed. So what will be the insert function now? So insert function would be somewhat like this. I have removed 1. I have removed 1 here, right? And I need to basically this function will call this thing, and it will get me this answer. Let me again, this should give me 2 3 4 and then 5, right? Yeah. So this we done, we did, and then I just need to put back the 1 here, right? That's easy. Exactly, right, that's easy because I just need to push back 1 again. So this is what our hypothesis is, right? And our induction in this case, actually our induction would be this, to put back 1. This will be our induction in this case. In this sub problems, our induction would be to push back 1 to this, so that our required output is matched with our current output, right? In our previous example also we saw, right, we saw exactly this. See, in our sub problem which was insert, our induction step was to push back whatever is left, right? Sorry. Yeah, so this is what our induction and hypothesis will look like. Now again I will just start writing the code because it's everyone understood this thing, right? Reversing a stack till now, because we are done
Yes.
with everything.
Yep.
Yeah, and our base condition would be like, if there's nothing in the stack, just push the number which is at the temp or val. Got it? It's as direct as the question, the thing which we discussed, sorting an array, right? So we can have one void insert. We will start with insert, right? We will start with insert. We have one stack, right, which takes an input int, and we will again pass this by reference, right? You know the reason why. So int let's take the, what we should take, yeah, int temp, because we are using that. So if, as I told, if the size, if the stack size, right, is 0, or you can also use is empty in Java, right? Is empty, make same thing. Push the temp, push the temp, right? So yeah, so that's our base condition in this case. Now I need to basically int temp is equal to s dot top, right? Okay, int val, basically we, because we are now again we are what we are doing in this case, for 1 we need to remove this, right? So we will store it in some val is equal to 1, right? And then we will pop it from the, so that our hypothesis is done. 2 3 4 5 we are getting, right? So this is why, this is how you will go step by step, right? We have stored our 1 in val, and then we will just pop. This pop will give me 2 3 4. This pop, this pop will give me this insert, right? And then we need to call insert again, right, which will take s and the temp, right? And after inserting is it again and again, we'll get one, we will get only 2 3 4 5. Then we will do our induction. How? Just pushing back the 1, the thing which we stored at value. We will just s dot push our val. Got it? And then just return. This is what our insert function will look like. Simple, nothing. It's exactly similar to our um, the sorting an array, right? So now our reverse function, let's say our reverse function will be, let's write also reverse function, which we actually had to do in this reverse. We need to write now reverse function. right? So I will also write reverse function because it's really direct now, right? There's nothing much to explain up. Reverse stack int s. It just this just takes only one stack, right? And again here, if s dot size is equal to 1, right, then just return. Because let's say that you need to reverse a stack which has only uh, wait, which has only one element. What will be the reverse of this? Nothing, right? Only one. There's nothing to reverse, right? So this is what our base condition means. Return, right? And you can also write that condition as well, that if the stack is empty, you can just return it, right? Now int temp, you need to store the temp as exactly how we did in our array, sorting an array. Then s dot pop, right? And then calling reverse again. And after I called reverse, we got this. After I called reverse, I got this. I got 1 2 3 1 2 3 4. Now we need to add 5, which we stored in temp, right? In this case, in the main problem we stored in temp. In this we stored in val. Please don't confuse. So after that I need to insert the temp back, so I can just say insert s and temp, and this will just again call that. So yeah, just return, done. Or you can, yeah. So this is what our problem will be, our reversing a stack. So is everyone clear with this? It's really easy, and it's really direct actually, right? So yeah. So if you are done with this, we will be solving one last question, right? Which will be our using recursive tree now. Fine. So this is what our IBH method was, like induction, hypothesis, then induction, then we wrote base case. We saw how base case can be written, and then we just did the problem, right? We can break the problems in many other things, and then we did. So yeah, so this is what we did. Now we will be using our second method, basically second method, which will be to solve one question, which is permutation, but with space. It's not normal permutation. Fine. So please note that it's not a normal thing. So in this case, we will be using the decision and recursive tree basically. And again, you will see how I have made that decision, how I am making that decision to choose this one. Okay. So let's say we have our input. I have one input. What this problem means, let's say we have our input as ABC. Fine, ABC in a string. I have given one input here, right? I need to output, hold on, I need to output what? I need to output these things. Let me tell. We need to add spaces as per the permutation. So we will say A, B, C. This will be one permutation because we are adding space, right? What can be other permutations? 1 A, B, C, right? Then another, we can say we can say A, B, C, right? And one more we can say as A, B, C only, right? And again, this problem has the condition that you don't need to consider the spaces as like here and here. I mean, basically, you
Before A and after C.
yeah, you don't need to consider that, right? You can make, I will tell you, like, this is not valid, right? You just need to enter the space between um, the letters, right? So you can also solve that if the question demands that you need to enter the space there as well. That will be your homework. It's like one line code difference, right? I will tell you that as well. Fine. So here you can see again, now judging the problem in these cases, we saw that we didn't have anything to decide, right? We just needed to you need to make some changes basically, and we saw the pattern, right? We don't need to make any decision. There was only one flow, hence we chose IBH method, hence we chose to make this input smaller and smaller. But in this case, we can see we have choices, we have decisions to make, we have decisions to make if I need to return a space bc, or I need to return a space c, or I need to return, so on, these four, right? So here in these questions, if you see a pattern that, again, the first thumb rule which I told you, let me just show you. What was the, where was it? It was, uh yeah, this thumb rule. This is important, basically. This is really important, right? If you can take decisions, then directly apply recursive tree. This is a primary approach. Like, if you see any question, like, just don't start with IBH, start with primary, see if you can make decision, then apply a recursive tree. Else then we can make input smaller using IBH method, which we were doing for the last two questions. Got it? So we will be using recursive tree here. Hold on, just, yeah, we'll be using recursive tree here. Fine. How? It's easy, it's not much again. So I have choices, so recursive problem. Again, that's our conclusion, right? Again, now for recursive tree, I will be making two things, right? One will be output, right? Output. And one will be our input, right? Exactly how I told you. I mean, this is just my way. I'm just telling you my way. You can use another kind of visualization to solve these types of questions, but this is just my way. Fine. And I have also learned it from somewhere else, so it's not exactly my way, but yeah, this is how I think. Fine. So let's say you have output as empty. Fine. And in the question you are given as a b c. Find this your given string. Find this your given string. Now you need to decide, you need to see if you need to include or not include. Basically, you are here, you need to include space or not. So you can be here, right? You can be in this part, but like, again, this is a hint for the question. If your question was given that you need to also basically add, you can add space before and after the letters, then you could have started from here only, right? Like, let's say that you are given, you chose not to take the space, so you just add a b c as in. And if you chose to take a space, right, then this would be our recursive call, and then you would have continued, right? But in this case, like, for as of now, like, this can be your homework, you can do this in your homework, like, you can solve this question. But considering the spaces, like, after this, you can, I guess, perform this again, not choosing the space, or yeah, or choosing the space, right? So you can choose the homework, you can do the homework, but in this question we will be just considering this path. We will be taking this path here, not like the spaces will come after a, so we will be taking this path. Hence I'll be writing it here. I will be continuing this tree, this won't this will be discontinued for now. I will be taking this key, this tree, right? So in this case, what I can do, I have a in this, let me write it a little bit more clear. Hold on. Yeah. So a b c. Fine. So now my pointer is, maybe you can just imagine the pointer is here, or like, it's, this is the output, right? This is the output and this is the input, so this is what we will follow. So I can maybe insert space before b, or not insert space. So this is what our choices would be. How did I decide? Easy, because this is what our output was, to, after a, to whether add space or to whether not add space, or like, you can answer these three cases, right? So this is why I'm using this thing. So whether to add space or not add space, what will be the output for this? It will be a space b, and in the input what will be left? C will be left, right? In this case I have not considered space, so I'll be writing a b in the output, and C will be left. Again, you can't pause the tree unless the input is empty. That's just a thumb rule for any kind of recursive tree, right? So you can say that our base case in every kind of recursive tree question, it's the same. Like basically your input should not be empty, right? So that's our base case. Again, now uh, I have two more choices in these both, right? I can whether I can take C with space or not with space. Here also I can take C with space or not with space. If I take C with space, it will be what? A, B, and C. I am not writing input because it's empty, right? So it's self-explanatory. And if I don't take space, it will be this. If I take space in this, it will be A, B, C. If I don't take space here, it will be A, B, and C. So your output, again, your basic output would be this. This will be your answer. So now you need to figure out. So this intuition is done. I mean the recursive tree is made. Now, as I told you, if you have figured out your tree, then writing the code is very easy, right? You just need to know your basics of data structures in whatever language you are coding, right? And then it will be a piece of cake, right? Writing the code will be piece of cake. So we'll start writing the code now. Fine. Has anyone have any doubt in recursive tree formation?
No, bro.
No. Yeah, cool. It's very direct. I also explained with using the permutation. Sorry, in the subset problem above. Right. So I will be writing code now. Yeah. So code. Uh, okay. Let's start with the code. Okay. So let's say that we have some int main function. I want to I want to make I want to basically input something, right? So I will be first calling my string IP, right? I'll be taking input. Basically, I'm taking my ABC, and I'm writing this in my int main statement because I need to get to this. I need to get to this thing, right? I don't need to continue solving this recursive tree, right? So I need to get here. Hence, I'm writing this in main function so that after this function is called, it directly goes to this condition and then it just solves it, right? If you are doing the homework, which I told you to include the space here, then you don't need to perform this int main wala thing. Fine. So, like you can just write cn input and then uh, what I need to do, I need to basically, I will also parallelly write it here. What I need to do. So let's say that I have again output, I have input. I have output as input as A, B, C. Fine. I've seen input and I will also declare string OP as some empty string. Fine. So these are defined. Cool. Now I need to do some operation so that my output becomes A and my IP becomes what? BC, right? And after this, we can have one function which recursively calls everything, which we even wrote here, right? A and including space. So we just need to get here. Hence, I'm writing it in this way here, string output. I mean, even for the homework question, you can do this. Obviously, you need to define OP, right? So now, after this, you need to push back. uh, if you're using string, you can use pushback. Yeah. So IP zeroth, basically I'm pushing the OP in the string OP. I'm pushing the zeroth of input A, right? And then after A is pushed, I also need to remove it from my input, right? So I can use something called as erase. I can use something called as erase, and this is a one CPP function basically, right? Which basically erases the input from the beginning. And plus 0 I have done just so to ensure that it is done from the zeroth element. I mean from the starting element, right? In Java you can simply, you can use ChatGPT and just see what will be the equivalent of this thing. Otherwise the code is exactly same for all the language. I'm just discussing the approach here. Fine. So now I will write one solve question which takes IP and OP. This is our recursive function which we will be making. So now comes the question, main question. Void solve which takes two strings which will be OP, IP and OP. Cool. Right. Now going back to this, what we did, we need to make decisions, right? So first we will write with base case. Our base case would be to return, like, okay, I will also tell you one flow of recursive tree, right? When we are recursively calling it this, then after, as the input becomes 0, here in every case input is 0, in the leaf nodes input is 0, this will call back here, this will go back here. Basically this will return and then just go back, right? So I will be writing base case here, right? If IP, it's very easy, IP dot length, because this is string, we need to use this, right? Or okay, let's go with IP length. Basically we need to just check if the input length is 0. If it is 0, then what, you just see out output, right, with some space maybe, and return, right? This is our base case, basic base case. Now let's say that I have one OP, string OP1 with OP, and string OP OP2 with again which has some OP, right? Why I'm doing this, let's see again. Let's continue with tree, our only tree. Fine. Now here I can include space or not include space. So this will be some OP1, this will be some OP2, right? What we are doing here is that after getting to this step A, B, we can either include space or we can't include space. So OP1, OP2 are some outputs, right? And that those outputs will be, we have discussed that, right? And then this will again call. So in these questions, in these recursive questions, you just need to figure out one step and then you can recursively call that and then your question is done. So basically you need to just try to get these two things and then you can just recursively call it and then your question is done, right? We will see how. Fine. OP1, OP2, we got something. How, what is OP1? Let's also see. Parallelly we will, oh sorry, parallelly in this case we will see that how we can form OP1, OP2. So what was OP1, OP2? OP1 was what? A space B, right? And our output was left, sorry, input was left as C, right? And in this case if we include only B, not space, so our output would be A, B, and C would be left, C would be left somewhere. Fine, these will be our OP1, OP2. So how I can write, I can modify OP1. Let's see. I can write OP1 as push back our, with my space, with some space, right? You can say OP1 push back space, and also OP1 you also push back whatever is in IP0, because again you can pass these string with reference, right? You should pass these strings with reference so that you know this IP0 it's taken after this is popped, right? So you need to pass it within reference IP1, IP OP1 pushback IP0. Fine. So this will give me, these two operations will give me this output, right? And C will be left. Fine. Till now this is good, right? Now I can also, now I need to also push back, need to take care of the OP2 as well. So this you need to push back OP0 only, right? Yeah, you need to only insert OP0 because there's no space, right? Now after you have done this, you also need to basically make your input erase, right? So I can say erase. I can again call the same function which I did, begin plus 0, because I just need to, as the recursive call happens, I just need to basically remove this C. Let's say that we had more number of letters in this input. It would always remove the like the upcoming, the zeroth letter in the string, right? Hence IP dot erase IP is 0, and then after this, what you should do? After this, you need to call the solve function again, right? Which takes input 1 and output 1, modified input 1, output 1, right? So you can just call, you can just say solve what? IP OP1, and again solve IP OP2. Done. Return. Done. Basically, what I'm doing here is that I'm calling solve so that this again makes two trees, this again makes two trees, and then this just return, and then some time it will get in this IP dot length see out output, and it will just return whatever is left in the leaf nodes. Fine. So this is what our recursive tree question is. Got it? Is everyone okay with this solution? Any doubts? Cause this was these so this was really used everywhere, even in the permutation question. You have to, now I guess you can also code this question as well, permutation question also, which I will be giving you as homework. Right, this question, let me just, I have defined somewhere here, right? Yeah, this question you need to, your homework, another homework is that this is your homework. Let me, this is your homework, right? This is your homework. You need to basically use recursive tree to, if your input is this, you need to output this ABC, not spaces and all. You need to input this. So I have made the recursive tree, and again similar, exactly similar pattern you need to follow, and then just use this recursive tree and solve this using this code which I did here. Where is it? Here. Got it. So this is hurt. So any doubts? If someone has any doubts, please unmute and ask. You can ask. So this is what we did till now. Yeah, no doubts. Fine. Uh,
Clear, bro.
yeah, cool, cool, cool. So yeah, this is what we discussed. We discussed two ways in our recursion. Just to wrap up, we discussed two ways. One was IBH, right, and one was this tree, recursive tree. The other two methods, which is TP, and another method is something which I will be explaining, like backtracking and all. It involves backtracking. I will be explaining in the in future classes. But till now, these two methods are enough for you to solve any question. Like I told you how to identify these questions, how to identify how you can insert recursion, use recursion, and then how to identify whether to use IBH method or the recursive tree method. Fine. So this is what we will be stopping right now, and yeah. So thank you all to uh, attend this class, and I'll be seeing you next week. So is that fine, everyone?
Yes, bro. Thank you,
Yeah. So
bro. And I'm having a question, bro.
yeah, sure, sure.
So, bro, I like to solve problems, but I don't like the coding part very much, bro. So,
Relatable, very relatable. It's genuine problem actually. Like you need to, you like basically solving the intuition, right? But you don't like
yes,
to
bro. Yes.
code. So for
Yeah,
that,
bro.
okay, so there are two things. First, like there are two types of people, right? First one are like they are majorly really interested to solve these, I mean write codes and all, because they might be doing competitive coding, or they might be doing some development or some coding activity in their time, right? So, and their second, people who have just started DSA, and they don't write to code, they just need to, they just love to write the intuition, which I do.
Yes,
But
bro. Yes, bro.
yeah, so what I would suggest is that first of all, do you do any kind of like, other than DSA, do you do any kind of other coding, like development or Android dev, or
Yes, bro. I am into machine learning. Yes.
you're into machine learning? So you like to code in Python maybe, right?
Yes, bro.
You can code, you can, okay, so in interviews you can use Python. Like I know my friend who is into Make My Trip, right? And he coded his way using Python only in his interview, right? But that was a special case. I mean, I don't know. It's not every time. It's not likable by everyone. I mean, I can't say likable, but it's not appreciated by everyone to use Python, because in Python, if you need to use some, let's say, sort function, or there's some other types of functions, there are many types of inbuilt functions already, right? So people get little bit comfortable with Python, and they just, write half codes and done. They are just done with it. So that's why I would suggest you to, have get some interest in solving CPP or Java, using CPP Java. Python is good. It's good for DSA also. But what I prefer is that you can do, what you can do is that once you have written the logic, you can code it in Python. Do you like coding in Python? So can you code
Yes,
your solutions in Python first?
yes, bro. Yes.
Yeah, you can try to code in Python. Maybe, like, you, if you get that habit to every time you write the logic and then you write the code in Python, maybe then you will start writing the logic in any form. I guess then that can develop some kind of habit in your day-to-day life, right? So you can write codes in Python also, but still I would suggest that stick with languages which are, a little bit Java, like CPP and or C, because again the same reason, Python has a lot of inbuilt libraries, and which is not much appreciated by interviewers, right? So again, special cases are there, but still, like, just to be in safe corners, stick with CPP or Java. Fine. Otherwise always, I would suggest to everyone, please just don't rely with DSA, right? DSA is just a part of a interview process. Like, many people, what they do is that they will be like, okay, I will do DSA, I will just do DSA for 4 years, right? They can, like, if you're going competitive, if you're doing CP, and if you are very good at it, then it's good. If you're only doing DSA and you're competitive programmer, and you go like very high level in very competitions and all, you won, then it's good, right? But if you are just doing DSA basics, lead code, you need to have another kind of a habit, or other kind of a coding profile, let's say web dev, or you can say app dev, or ML, machine learning, like he said, data science is also there. You can also get into cyber security, right? So because what happens is that in interviews, first round first round will be the online coding rounds, which will have DSA, obviously. Okay, DSA will be there. There will be computer basics, networking, DBMS, right? DBMS, right? This will be some online coding round, right? If you get past to it, you will have one technical round, which will be of just DSA, like, live coding. Again, this is different from for every company, but I'm just giving you one case, right? Then let's say that you get into DSA live coding. Fine, cool, you got into coding. Okay, next step comes with some discussing your projects, or your resume, your past internships, right? What you do, basically what you are doing exactly. So in these, like, many people get, rejected if they just stick with DSA. If you are good competitive coder and all, maybe then your resume can be, very good, and then you can maybe crack this interview, right? You can go to HR round and then crack this interview. But again, those cases are very less, right? So you need to have some other activities like web dev, AI, ML, data science, something which is relevant, and your project should be relevant. It should be live problem solving, it should solve real world problems as well, right? So please try to just don't rely to DSA. You need to balance everything now, right? If you are in the second year, you have time to balance. You can start learning. But if you are in third year right now and you're listening to this recording, or you're in live class, please, it's high time you start something different as well, side by side. You start something web development or app development. You start making some projects, right? You can start ML, you can start data science. It's really popular right now. So You can participate to hackathons like Google has launched its Gemini AI coding hackathon, right? So there you can use Gemini AI to make some projects, and that's a really good hackathon. You can win crazy prizes, but that will reflect in your resume. It will be really good for you, right? So just don't rely with DSA. And if you are finding problems, if you are doing your ML part good and all, and if you are finding problems in DSA, then man, like again the guy who asked right now, you need to pass the screening round, right? Without coding you can't basically pass to directly to this projects and resume discussion round. So you, like, there's no choice right now, you need to still do DSA. You need to code this way out. If you write Python, if you like Python, you can write codes in your Python. uh, but I will still suggest that try to stick with CPP or Java. Fine. You need to get that habit. You need to get into that habit. DSA again, it's not that much fun if you are just here for cracking the round, interview round. If you genuinely like it, then it's fine, it's also good. But if you are just here for interview round, cracking the interview round, DSA is not that much fun, I would say. Even I like my cloud and web dev more than DSA, but that doesn't mean that I would ignore DSA, right? You need to still do DSA to switch jobs in future or get the first internship and job, right? So yeah, so even if you don't like it, there's no choice, man. The population is very high. Companies have to use some screening round to sort the best candidates. So you need to do DSA. You need to find the way out. Like if you like to code in Python, maybe code your logic in Python and then try to convert it into CPP or Java, right? Or maybe just stick with Python and explore it with your seniors, that whatever companies that came into your college, were they comfortable with Python? So this is also subjective. Hence, I'm just being like, just to be safe, do CPP and Java. So yeah, that's what I will like to suggest right now. And yeah, any other questions?
No, bro.
Yeah.
Thank you, bro.
Okay. Cool. So okay. Thank you. So we will be meeting next class. Okay. Cool. Bye.